Have you ever stopped to think about the giant ships that quietly keep the world running? Every smartphone, car, television, and even the food on supermarket shelves has likely crossed an ocean before reaching you. But behind this global trade is a new generation of ships that are bigger, smarter, and more advanced than anything built before. Over the last 2 decades, China has transformed itself into one of the world's leading shipbuilding nations, producing vessels that are changing global shipping, offshore construction, scientific research, and even energy production. From container ships that carry entire cities' worth of cargo to floating platforms that drill miles beneath the ocean floor, these engineering marvels are redefining what humans can build at sea. Today, we're counting down 10 incredible Chinese ships that showcase the future of maritime engineering. And trust me, the number 1 vessel isn't just another ship. It could completely change how remote regions generate electricity. Let's begin. At number 10 is the COSCO Shipping Universe, one of the largest container ships ever built. Measuring over 1,300 feet in length, this giant can carry more than 21,000 standard shipping containers in a single voyage. That's enough cargo to fill thousands of trucks. But its size isn't what makes it truly remarkable. The real innovation is how efficiently it operates. Every container loaded onto the ship is carefully positioned using advanced computer software. The system calculates the exact location of each container based on its weight, destination, and unloading sequence. This keeps the ship perfectly balanced while reducing fuel consumption throughout the journey. Its streamlined hull has also been designed using advanced computer simulations to reduce water resistance, allowing it to travel more efficiently despite its enormous size. Surprisingly, only a relatively small crew is needed because many onboard systems are automated. Today, vessels like the COSCO Shipping Universe connect hundreds of ports across more than 160 countries. Every year, they transport millions of products that eventually appear in homes around the world. Modern global trade simply wouldn't function without ships like this. Coming in at number 9 is another maritime giant, the Haiyangshiyou. Unlike container ships, this vessel carries bulk cargo such as iron ore, one of the world's most important industrial raw materials. With a deadweight capacity of around 400,000 tons, it ranks among the largest bulk carriers ever built. A single voyage can transport enough iron ore to manufacture approximately 50,000 vehicles or supply steel for numerous skyscrapers. The biggest advantage isn't just its carrying capacity, its efficiency. Instead of using several smaller ships, one Haiyangshiyou can complete the same task while consuming less fuel per ton of cargo. Building a vessel this large required solving enormous engineering challenges. Engineers carefully designed the hull to reduce drag while maintaining stability under extremely heavy loads. Sophisticated ballast systems automatically adjust the ship's balance as cargo and fuel levels change during long ocean crossings. When fully loaded, the vessel sits nearly 75 feet below the waterline, meaning only specially designed deep water ports can accommodate it. By transporting huge quantities of raw materials in one trip, ships like the Haiyangshiyou help reduce transportation costs and improve the efficiency of global steel production. At number 8 is the Haiyangshiyou 2, also known as Snow Dragon 2. This remarkable vessel represents China's entry into advanced polar exploration. Unlike ordinary ships, the Haiyangshiyou 2 is designed to operate in some of the harshest environments on Earth. Its reinforced hull allows it to break through thick sea ice by riding onto the ice and crushing it under its own weight. One of its most impressive features is its ability to break ice while moving both forward and backward, giving it much greater flexibility than many traditional icebreakers. Inside, the vessel contains modern scientific laboratories where researchers study climate change, marine biology, ocean chemistry, and polar ecosystems. The ship can travel more than 17,000 miles without refueling, allowing scientific missions to continue for months in remote Arctic and Antarctic regions. Advanced radar, satellite navigation, sonar, and weather monitoring systems help the crew safely navigate constantly changing ice conditions. For scientists, the Haiyangshiyou 2 is far more than an icebreaker. It's a floating research station helping expand our understanding of some of Earth's least explored environments. At number 7 is one of China's greatest offshore engineering achievements, the CNOOC 981 deepwater drilling platform. Although it floats on the ocean, this massive structure functions more like a small industrial city. Standing on its deck, it's easy to forget that nearly 10,000 feet of water lies beneath it. The platform can drill several miles below the seabed in search of oil and natural gas trapped deep inside underground rock formations. Keeping such a massive structure stable is an engineering challenge in itself. Instead of relying only on anchors, the platform uses a sophisticated dynamic positioning system. Computer-controlled thrusters constantly adjust its position by responding to waves, currents, wind, and GPS signals. Thousands of sensors continuously monitor drilling operations, pressure, vibration, and equipment performance, allowing engineers to detect problems before they become serious. Designed to withstand powerful storms and harsh offshore conditions, the CNOOC 981 demonstrated that China could independently build and operate advanced deep-water drilling technology. At number 6, we enter one of the least explored places on Earth with the Dayang Hao. Unlike cargo ships or drilling platforms, this vessel serves as a deep-sea research ship equipped with advanced robotic systems capable of exploring extreme ocean depths. Its remotely operated and autonomous underwater vehicles can descend nearly 36,000 feet, reaching areas close to the deepest parts of the world's oceans. These robotic explorers collect rock samples, map the seabed, study marine ecosystems, and investigate valuable mineral deposits rich in metals such as cobalt, nickel, copper, and manganese. Modern sonar systems create highly detailed maps of underwater mountains, valleys, and hydrothermal vents that were once completely hidden from human knowledge. Artificial intelligence also plays an important role. AI-assisted software helps scientists process enormous amounts of data collected during each expedition, allowing researchers to identify important discoveries more efficiently. Maintaining the vessel's position above these underwater robots requires extremely accurate dynamic positioning technology. Even slight movement on the surface could affect operations thousands of meters below. The Dayang Hao demonstrates how robotics, automation, and marine science are opening a new chapter in deep ocean exploration. We're only halfway through our countdown, but the engineering achievements only become more impressive from here. Next, we'll discover a floating construction giant capable of lifting 12,000 tons, an advanced aircraft carrier equipped with electromagnetic launch technology, one of the world's largest container ships, an incredible floating crane that helped build one of history's longest sea bridges, and finally, a revolutionary floating nuclear power plant that could transform energy generation far from land. At number 5 is a vessel that proves building in the middle of the ocean is no longer impossible. Meet the Haiyangshiyou 982, one of China's most powerful semi-submersible crane vessels. Unlike ordinary cranes that stand firmly on land, this floating giant performs heavy lifting while waves, wind, and ocean currents are constantly moving beneath it. Its twin cranes can lift an incredible 12,000 tons, enough to raise massive offshore platforms, giant bridge sections, or the foundations of offshore wind turbines. But lifting huge structures is only half the challenge. The real achievement is placing them with astonishing precision. To accomplish this, the vessel relies on an advanced dynamic positioning system. Multiple thrusters, satellite navigation, and thousands of sensors continuously monitor wind speed, wave height, ocean currents, and the ship's movement. Powerful computers instantly adjust the vessel's position, allowing engineers to install massive offshore structures with remarkable accuracy. Its semi-submersible design provides another advantage. By filling ballast tanks with seawater, part of the vessel sinks deeper below the surface, creating a much more stable platform for heavy lifting operations. Over the years, ships like the Haiyangshiyou 982 have played an important role in constructing offshore oil platforms, installing giant wind turbines, and supporting major marine infrastructure projects. It demonstrates that today's construction industry no longer ends at the coastline. It now extends far into the open ocean. At number 4, we move from commercial engineering to one of the most advanced naval vessels ever built by China, the Type 003 aircraft carrier Fujian. Stretching more than 1,000 feet long and displacing around 80,000 tons, the Fujian is essentially a floating airport capable of carrying dozens of fighter aircraft and helicopters. Its biggest technological breakthrough is the use of an electromagnetic aircraft launch system, often known as EMALS. Older aircraft carriers use steam catapults to launch aircraft. The Fujian instead relies on electromagnetic force, allowing smoother and more efficient launches. This technology enables aircraft to take off carrying heavier fuel loads and equipment, increasing both range and operational capability. The enormous flight deck is supported by advanced elevators, maintenance facilities, fuel storage systems, and sophisticated radar and communication equipment. Automation also plays a major role, helping reduce crew workload while improving operational efficiency. Building an aircraft carrier requires expertise in shipbuilding, aviation, electronics, power generation, and advanced manufacturing. The Fujian represents years of technological progress and demonstrates China's growing ability to design highly complex naval vessels. Taking the third position is another masterpiece from COSCO, the COSCO Shipping Galaxy. While the shipping universe was already enormous, the Galaxy pushes container shipping even further. This Megamax-class vessel can transport around 23,000 standard containers, making it one of the largest container ships operating today. Containers are stacked as high as a 20-story building, yet despite its massive size, only a small crew is required thanks to extensive automation. Engineers designed its hull using advanced computational simulations to reduce drag and improve fuel efficiency. Even though it carries more cargo than previous generations of ships, it actually consumes less fuel for each container transported. Its powerful engine produces well over 100,000 horsepower, allowing this floating giant to maintain steady speeds across some of the world's busiest shipping routes. A single voyage can deliver enough products to supply thousands of supermarkets, making ships like the Galaxy an essential part of modern international trade. At number 2 is a ship that many people have never heard of, yet its work has helped build some of the world's most impressive infrastructure. Meet the Genoa 30, one of the world's largest floating crane vessels. Built by Shanghai Genoa Heavy Industries, this engineering giant can lift 12,000 tons while maintaining extraordinary precision even in challenging sea conditions. Its greatest achievement came during the construction of the Hong Kong-Zhuhai-Macau Bridge, one of the longest sea-crossing bridge systems ever built. The Genoa 30 carefully positioned massive bridge sections, each weighing thousands of tons, while waves, tides, and currents constantly pushed against the vessel. Its sophisticated dynamic positioning system continuously adjusts multiple thrusters to hold the ship almost perfectly still. This level of accuracy allows engineers to complete projects that would have been almost impossible using traditional construction methods. Today, vessels like the Genoa 30 continue supporting offshore wind farms, oil platforms, ports, and major bridge projects around the world. And finally, we arrive at number 1. Unlike every other vessel on today's list, this one isn't designed to transport cargo, explore the ocean, or build offshore structures. Instead, it has the potential to generate electricity almost anywhere. China's concept of floating nuclear power plants, based on small modular reactor technology, represents one of the most ambitious ideas in modern maritime engineering. Instead of constructing large nuclear power stations on land, engineers are exploring compact reactors that can operate on floating platforms. These systems are designed to provide reliable electricity for remote islands, offshore facilities, coastal developments, and other locations where connecting to a traditional power grid would be extremely difficult or expensive. Small modular reactors are much more compact than conventional nuclear plants and are designed with multiple safety systems and modern cooling technologies. A floating power station could remain at sea for years while supplying clean, continuous electricity without depending on fossil fuels. Although projects in this field are still developing, they demonstrate how maritime engineering is expanding far beyond transportation into entirely new areas of energy production. From enormous container ships and giant bulk carriers to polar research vessels, deep-sea exploration ships, offshore construction platforms, aircraft carriers, and floating nuclear technology, today's countdown shows just how rapidly maritime engineering is evolving. These vessels are more than impressive machines. They represent advances in automation, artificial intelligence, robotics, energy, transportation, and scientific research that are reshaping how humans use the world's oceans. As technology continues to improve, the next generation of ships may become even smarter, cleaner, and more autonomous than anything sailing today. So, which of these incredible vessels impressed you the most? Was it the giant container ships moving global trade, the deep-sea research vessel exploring the ocean floor, the precision of the Genoa 30, or the futuristic concept of floating nuclear power? Let us know your favorite in the comments below. If you enjoyed this documentary and want to explore more of the world's biggest engineering projects and breakthrough technologies, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next documentary. Thank you for watching, and we'll see you in the next video.